There were no diseases in the ostial of the LAD or the circumflex at that time, although the stent place was in the proximal segment of the LAD and the circumflex arteries, respectively. His current EF is 53% from echocardiography, and he's got a normal renal function, but severe COPD, for which our surgical colleague has turned him down for surgery. Now, this is a still frame of his angiogram. You see here a distal left main, probably about 90-95%, an ostial LAD, high grade, and a long segment of the ostial left circumflex, quite typically known as the Mercedes-Benz sign. The right coronary artery is normal with small collaterals supplying the LAD here. And from the syntax score, we obtain a score of 26 for the distal left main, ostial LAD, and ostial left circumflex. No other segments were involved. Now, in this patient, we had to do percutaneously, and we chose an 8 French side hole catheter. It is important to use a side hole because sometimes when you engage a catheter in this critical left main, the patient may crash. Now, for this subtotal lesion or critical lesion, we chose a very thin wire which we use for CTO called Fielder FC. This is a soft wire and usually crosses quite well in subtotal lesions and even total lesions sometimes. Similarly, we have a Fielder FC wire in the LAD, but once you place the wire, you should watch the ECG and blood pressure, because sometimes once you cross, even with the wire, the ST segment can go up or go down, and the blood pressure can crash. In this patient, what we did actually was prepared the balloon ahead of time. The 2 balloons were on 2 separate wires in the guide from the outset. We had 2 different indiflators of different size. The LAD being the larger artery, we have a larger indiflator so that we don't get mixed up with indiflators. And for the first inflation, we chose a 1.5 balloon, a sprinter, left main to left circumflex for 10 seconds. And then a separate 11.5 balloon, left main to LAD for another 10 seconds. And then establish flow. Once you've established good flow, you can relax a bit and then take the second balloon now. We chose a 2.5-15 to inflate for 15 to 20 seconds in the circumflex left main. The same balloon was used to dilate the LAD left main lesion. Now you have much better flow, and then plan accordingly. What we chose to place was the first stent in the more angled lesion, the circumflex lesion, the longer lesion. And this was a 3.5 times 20 millimeter Promus element stent, which was just available at that time because of its higher opacity and good radial force. And we sized the stent to the size of the circumflex, which was 3.5. And then subsequently, this is an additional step that I now do. I post-dilate the proximal segment of the stent in the left main with a 409 NC Sprinter at 18 atmospheres, so that the stent struts are now completely open in the left main segment. This is what is called proximal optimization of the stent. Then we rewire the LAD again across the stent in the left main to circumflex, and we chose a Xeon wire because of its better trackability and good torque control. And then dilate the stent struts in the circumflex with a 2015 Sprinter balloon to permit further interrogation with subsequent balloons and stents. Now, what are the issues in rewiring after the left circumflex has been deployed to the left main? First, the wire can go underneath the under-deployed stand in the left main, and that could be disastrous. But with left main optimization, you reduce this possibility. Bear in mind, the left main is always larger than the circumflex and the LED, and it's a sum total of the other two. And sometimes it's difficult to rewire the LED, especially if you have calcification involving the ostial LED, which is not uncommon. Now, why do we do left main proximal optimization? We choose a high-pressure balloon and size it to the left main, here a 409 NC Sprinter, so that you can open up all the struts that is in the left main. Bear in mind, the stand that we chose was sizing to the circumflex, which was 3.5. The left main is 4.0. You have to open up the proximal segment so that you get a good, round, complete deployment of the stand. If you choose to do a kissing balloon to obtain this, quite often you find that you end up with an elliptical left main. And this is confirmed by a present study from London, Carlo Di Mario, who are using the IVUS and OCT devices. Now, the advantages of proximal optimization, as I discussed earlier, it facilitates the recrossing of the LED once you've deployed your stand from left circumflex to left main. It avoids wire passage below the struts. It avoids an elliptical deformation of the proximal stent in the LED in the left main, and avoids malapposition of the proximal stent. If you fail to rewire again, one other trick that I use is to get hold of the Crusade catheter. This catheter has the dual lumen. The distal lumen exits the RX wire, and the proximal lumen facilitates the passage of the OTW wire. Another version of this is, of course, the twin pass from US. This is from Japan, the Crusade catheter. So that you know, if you follow the RX wire, you know you're in the true lumen of the stent. Now, this is a cartoon to show the deployment of the circumflex stent. This is the LCX wire, the LED wire. The LCX stent is sized to the size of the circumflex, here 3.5. So the proximal segment of your left main is still 3.5. There is a small gap here of 0.5, the left main being 4 millimeter. So quite often you get your wire going underneath the strut of a stand. Now, to avoid this, if you have not optimized the proximal segment of the left main stand, you can bring in the Crusade catheter, you know, in the true lumen within the stand, and then facilitate the passage of the wire to the other segment. Now, what are problems of advancing the second stand once you place the first stand from the left main to the circumflex? In calcified left main, this can be an issue. Similarly, in wide-angle left main bifurcation beyond 75 to 90 degrees. Now here, in order to avoid a stand hitting another metal stand, what I do is to bring in a child catheter from Terumo, hard rail, or if you have a guide liner, it acts the same way. By bringing in this catheter into the stent, you now avoid metal knocking against metal, and you can facilitate the passage of your second stent quite readily. In this patient, we could place the LED stent quite readily without the use of a guide liner or a child catheter. Here we chose a